Today's lesson in math is lesson 31, session 3, and I'm on page 683. And our first problem that we're supposed to be considering, it says to draw a 30-degree angle and think about using two pencils to make an angle. So what I don't have pencils on me today, but I do have chopsticks. So I want to show you guys how you can use two straight objects to kind of think about different angles. So I know that if I put these two together like this, I get a perfect 90-degree angle. And I'm going to go ahead and try to trace this as best as I can to show our 90 degrees, just so I can then provide a protractor to show you how it measures appropriately. I think it's adjusted a little. Okay, so now I have the start of a 90-degree angle. And I'm going to go ahead and cover it with my highlighter. That way it looks a little more defined for us. Okay, so I've created, as you can see, a 90-degree angle using my two chopsticks. Now, recall that when we have a total amount of something, we can break it up into parts. And we know that a 90-degree angle, this angle right here, or the right angle rather, is 90 degrees. So, and what we are trying to consider is, well, how could we make a 30-degree angle? Well, I know that 90 is a multiple of 30, and there's actually three groups of 30 that go into 90, because 30 plus 30 plus 30, or 30 times 3 is in fact 90. So I can kind of look at this space and imagine how I could break this space up into thirds. So I'm going to kind of look at it, and remember we'd have to break it up from our vertex, which is the point where the two rays meet. And I'm going to say that maybe, what do you guys think? That maybe a third might be here, and then another third here. So I'm going to try and break that up. I think it might be, I'm just going to kind of draw a line and see if this would make sense. So I've tried to break up this space by thirds, and now I'm going to use a straight edge protractor, which is kind of hiding over on the side, and try and see if I can make these into 90-degree angles toward the vertex. Okay, so what I've done here is I've just kind of eyeballed this 90-degree angle and tried to break it up into thirds. So I have 1/3 here, 1/3 here, and 1/3 here. And hopefully, if I measure them, I'm about correct on the 90-degree angle. I'm gonna have to make my lines longer though, because remember, my protractor is really not very user-friendly because it is not see-through. So I have my lines here, and remember you put the dot of the protractor on your vertex, and your line should line up with this degree down here. And then I can remember if it opens to the right, we have to use the inside numbers, and I can see that it does in fact go nearly directly through 30 degrees. So I've done a pretty accurate job in just eyeballing how I could break up this 90 degrees. Can you guys think of another way that you could break up 90 degrees into parts? Or you can kind of guess an angle? Well, I'm going to try it again, and I'm going to go ahead and I'm just going to do a 90-degree angle. And another very common angle is 45 degrees. And we know that 45 is half of 90. So what we could do is when we have a 90-degree angle, we could look at half of this space, which I think, so half of this space here to here is probably about this area. So I'm going to draw a little line right there. And I'm going to go ahead and connect to my vertex and go out so I can actually measure this line. So what I've done up here in the top example is I've divided the 90 degrees into 30 degrees just by eyeballing it. And we know that 45 plus 45 is also 90 degrees. So we can divide this 90 degree portion by half and get 45 degrees in each section here. And 45 plus 45 is 90. But let me measure and see how accurate I am. Again, I just kind of eyeballed it. And over time, as you continue to do this on your own, you might get a better skill. It looks like I am off by a little bit just in my eyeballing. So the actual 45 degree line would come about right here. But you see kind of, or you can get a feel and understand what I mean by cutting this, this area in half. Essentially is what we're doing when we do 45s. Okay, so we're gonna move on now to page 684, and this model it is showing you kind of exactly what I showed you before, in that it broke up the 90 degrees into 3 sections of 30 degrees, and then you can measure each individual angle to get that 30 degrees plus 30 degrees plus 30 degrees. So a 30 degree angle opens about the same as the angle shown at the right. So this is a 30 degree angle right here. Now I've moved on to page 685, and number 1 says draw a ray on a sheet of paper. Then place the protractor's center point on the end point of your ray. What part of the angle is that point? Okay, so when we do that, and we draw a ray, I'm just going to draw a ray right here. And remember, this is a ray because we have a starting point and then we have an arrow at the end. So this is a ray. Now the actual question asks, when we put our actual protractor on this point right here, what is that called? Well, it then becomes the vertex of our angle, right? So this point is going to be the vertex. Okay, let's go on and see what it wants us to do again. What part of the angle is that point? It is the vertex. Keeping the protractor's center point on the end point of your ray, draw a point on your ray at 0. So the way that we're going to do that is on my ray, I have to put this on the vertex, and then so this point right here is going to be 0. And remember, 180 is the same as, if I was going by the inside numbers, I'd have a 0 right here, but I don't on my protractor. So, but I have drawn a point along my ray at the angle of 0. Now, keeping the protractor's center point on the end point of your ray, draw a point on your ray at 0. We did that. There are 2 marks on the protractor labeled 30. Choose the one that is 30 from your 0 mark and draw a point at this mark. Okay, so what we're going to do next is we're going to do this. And remember, I'm going to look at the inside and I'm going to see my 30 is right here. So I'm going to draw a point directly underneath that 30. Okay, so your diagram should look something very similar to this. And this is how you can draw accurate angles. And you will have to do this for some of your coursework. So use the straight edge of the protractor to draw a ray from the vertex through the point you drew at 30 degrees. Okay, we're going to draw another ray. We're going to start at the vertex and we're going to put this edge kind of at the top of that point, so it'll go right through it. And here is my second ray that goes through the 30 degree point that I marked. So suppose you choose the other 30 mark and draw a point at that mark. What would the measurement of your angle be? So when we lined this up, if I had have chosen the 30 degrees all the way over here, which is going to probably put me, it's off my paper, but I'm imagining it's going to be about right here. What would this angle now measure? And we would use still using the inside because we're opening from right to left, it would be 150 degrees if I were to draw that ray out. but I've made a 30-degree angle, and the way that we finish off our picture is we put this curve here to show that this is an angle, and on the inside you write the degree measurement. And that would have been 150 degrees. Think about a right angle. Compare it to the angle you drew. How wide does your angle open compared to the right angle? So how wide is this angle right here opening compared to a right angle? And I can draw, using the same method, my right angle. I'm going to put it right here at 90. I'll go straight up. So now I know that this whole angle right here is a 90-degree angle. And how this compares is this is 1/3 of the value of the 90. Even though to me, just kind of looking at it, it looks like it could be closer to 45 degrees. I know it's not because I actually measured it using my protractor. So how does it compare? This one is 1/3 of the value of the 90. How wide does your angle compare to the right angle? Smaller by 1/3. Okay, so now let's go ahead and move to page 686, and we're going to do a couple of these examples together before you begin your bookwork on your own. And number 8 says angle D measures 80 degrees. One ray of angle D is shown. Draw another ray to make angle D. Okay, so I'm going to have to lengthen out my lines so that I can measure better. Okay, and it says 80 degrees. We want an 80-degree angle. Oops, if that were to move, it's not going to help me. It looks like I'm a little off in how I drew it too. So we want 80 degrees. Now, so we're opening, you can see our base ray is pointing to the left, so I'm going to have to use the outside numbers for this one. I'm going to put that up on 0. And I'm in the center, and I'm going to look around to the 80 degrees, which is on the outside here, and it also is the 100 degrees on the inside. I'm going to draw my point, and then I'm going to connect my point to the vertex. And now the important part that we would want to finish off our angle, we're going to do this curve to show it's an angle. We're going to write the degree measurement, which is 80 degrees. And this tells me angle D. This point right here is labeled D because this is angle D. So I'm going to label it D, draw this curve, and write the measurement of the angle here. Okay, so our next two are drawing angles of our own. Because I have more space to the right, I'm going to draw my angles open to the right. So we have a 75-degree angle, which is going to be pretty close to a right angle, but not quite. We said 75, I think. Is that right? Yes, 75. So let me reline here. And I see, again, I'm going to use the inside numbers because I'm going from the right, and 75 is right here. Connect my two dots and draw my ray. And then this represents angle, and it is 75 degrees. So this would be finishing this angle because we don't have a variable or a label like angle D that we did above to put at this point. Okay, so next I have a 100-degree angle to make, and we know that this one is going to be wider than a right angle simply because it's 100 degrees. And again, because I'm opening to the right, I'm going to use the inside numbers. I'm going to go all the way to 100, just right here. I'm going to connect my 2 points to draw my next ray and do my angle. This is 100 degrees. So after this lesson, you guys will be prepared to work on page 687 and 688 on your own.